morning, John.
Good morning, Mr.
Good to see you.
And you, and you.
Can you explain, where are we?
Okay, this morning we are in Matrix Technology Solutions, it's our company, and we're based in Halifax in the north of England.
In the north of England?
In Yorkshire.
In Yorkshire?
Yes.
And what a great place is it?
We like to think so.
You run this company, Matrix, how long? How long is the company?
We started 23 years ago.
Okay.
When we started, we were called Matrix Multimedia, and we made CD-ROMs. We were a CD-ROM publisher.
Okay.
And we did that for about 7 years till the internet came along and destroyed that business, and we had to diversify. And so we diversified into electronics and into education in particular.
Successful?
Sometimes. Some years it's more successful than others.
Okay, and you develop and design your own products?
Yeah. Next door, in the room next door, we have 7 engineers who are all degree qualified in engineering, electronics and computer science. So we have a really strong design and development team, and downstairs we have some manufacturing people. And we have about 20 people in the company altogether.
What is your flagship product?
Well, our flagship product is a piece of software called Flowcode that maybe you've heard of. And what Flowcode does is it basically uses flowcharts to allow people without a huge amount of coding experience to develop complex electronic systems. We can all understand flowcharts. Sometimes programming in C or other languages is a little complicated and time consuming. So Flowcode has a lot of components to it with libraries and things, and lots of features that allow people to design complex electronic systems quickly.
Okay, and that is special aiming for education, or is it for businesses as well? Is there a special group of people you're looking at? Or?
You know, it started as an educational product back in the year 2000 with the first version we launched, but as it got better, more and more businesses have taken it up. And for the last version of Flowcode, I think we have something like 3,000 industrial users. And these users, the profile of the kind of people who are using it is people like test engineers who want to make small test rigs. Their speciality is not coding, or they're making small heating systems or small internet publishing sensor platforms, things like that. So it's not used by people for designing the electronics in a car, but it certainly is used by the automotive test departments where they're testing parts of a car. When we are thinking about product development, we are always thinking about how we sell more of existing product to a new market, how we are selling new products to an existing market, or how we are selling new products for a new market. And here on the table, I have an example of each of those. First of all, this product. Now, this is a range of products that allows people to understand how electronic systems or electrical systems are made. And it's a fairly simple system where what we have is a baseboard here with a number of components on, and they add components, and the strength is that as they add the components, they are forming a circuit diagram. And of course, the trick in learning electronics is to understand how the performance of a system is dictated by its circuit diagram. So if you want to fix it or design it, the circuit diagram is a key point. And this is called Locktronics, and it's been around for 40 years now as a product.
40?
Yeah, 40.
My goodness.
We bought it in 2008, and we've refurbished it. And this particular set of Locktronics here is all about electrical installation. And so here we have a domestic installation. There's AC voltage going in. There's a residual current device here, a circuit breaker. Here's some lighting, a couple of lighting circuits, if you like. And this shows how you can understand the different types of faults. So here, for example, I'm mimicking a short circuit, and in this case, this circuit breaker has blown, but the residual current device is still there, and I can reset the system like that. Now, here, this switch is simulating an earth fault, where basically from the live back to the consumer unit, if you like, there's a fault of 30 milliamps going down there. And then you can see here the residual current device has broken, and I can reset it like this. So it mimics the consumer unit that you have in your house. But actually it's a real high-tech system, because the guys next door have developed this little residual current device which works on just 12 volts AC, and it's actually a PIC microcontroller with a transformer. It works in exactly the same way as a 240 or 220 volt system, and it's a real high-tech device which is used to teach these electrical installation guys how things work. So that's a little bit of innovation, allows us to sell an existing product to a totally new market. Here's an example of innovation in the microcontroller learning world. And Arduino, of course, has done very well for setting the standard here. And of course, you ask yourself, well, how do I compete with Arduino? And so here we've done it in a couple of ways. We have this nice plate with a circuit diagram printed on, which makes it very easy for the students to understand what they've got to do. But also inside our own microcontroller development products, we now have a technology called Ghost. And Ghost is an oscilloscope, it's a logic analyzer, it's a packet decoder, and so it allows people to view what's going on in the system in a different way. Here's another example of, in the robotics platform, the robotics market, that again is quite a competitive market. And we've been in this market for 5 or 6 years, and our products are now, the sales are declining, and so we've reinvented this product. And this is called Allcode. It's a little robot buggy. It's got a powerful DS pick behind there, and it works on Bluetooth. Now, this is really clever because one of the problems in education is you can no longer predict what students are going to use to learn. At one time, there was just a PC and a Mac, but now they're using tablets, mobile phones, they're using Raspberry Pis. And this has a Bluetooth interface on and a little operating system, an API. Okay. And it works with any computing platform. Okay. So there's a library, and it allows students to use a really wide variety of different devices. So with App Inventor on a mobile phone, you can control this. You can control it with a PC with a Bluetooth interface using C++ or Visual Basic. You can use our own Flowcode software to alter the code in there. And you can use Scratch. So you can use a really wide variety, and it's a kind of, we've developed a brand for this called Allcode. And the idea is that you can use it with any kind of code you like. So Python, Raspberry Pi, whatever. And it actually works really well. Yeah. And it's interesting that it works better with a Raspberry Pi than it does with a PC, because the Raspberry Pi is so simple.
Talking about Raspberry Pi, you just showed me that you also on the table you have another product with Raspberry Pi inside. There are 4 PLC type packages here. What exactly are they representing?
Well, this is those people, those sort of viewers who know something about the industrial control market will recognize this kind of standard package, where this is a controller that fits onto a DIN rail, and it has inputs and outputs. And what we have here is something which is a good example of a new product for a new market for us. I always look at it, there are 2 worlds out there, the electrical world and the electronic world. The electronic world is into microcontrollers, the electrical world is into PLCs and industrial controllers. And there's a place where those 2 meet. So there are people out there who want to do industrial control with a tool chain that they're familiar with. And so what this series of products does is it allows people to use probably the current software that they've got. So we've got different types of microcontrollers inside these industrial controllers. So this one is our Allcode device. It's got a Bluetooth system inside it, and you can use C++, LabVIEW, Scratch, whatever you like. This one is a DS pick, so it's got a powerful 16-bit DS pick in it. This one has a Raspberry Pi inside it, so you can program that remotely using a remote desktop technology. And this one is an Arduino, so you can just use the Arduino toolchain. And basically what you've got is a lot of analog or digital inputs, 4 relays, 4 motor control outputs. It does RS485, RS232, CAN bus, lots of other things, direct USB programming.
It's ready to run.
And it's a real high-spec device, and it's brand new for October this year.
This is your place. I miss the soldering iron. What are you doing all day?
I don't know if I miss the soldering. I don't think I'm very good at that. These days I'm better at this, but I did start soldering, and I think I've done most jobs in the past. Yeah,
good. But including coding.
Including coding a long time ago. Yeah, I did do some coding, but the truth is I am a jack of all trades, master of none, and there are people here who are much better at any individual task than I am. Certainly.
Okay.
Sort of spend a lot more time with spreadsheets and PowerPoints and Word than I do with, coding, soldering irons and things like that.
What do you prefer, PowerPoint or a coding environment?
I think PowerPoint. I think I'm better at that than I am at coding. You like to do what you're better at, I think. Yeah.
Yeah. Okay. What have you got on PowerPoint then?
I've got millions, Vissa. They'll take all day. Yeah, I think monitoring how your products are doing and thinking about how long they're going to last in the market is really important. when you're in a technology-orientated business, things change. And the more high-tech your business is, it's likely the shorter your product life cycles are. So your sales can ramp up really quickly, but they can also ramp down really quickly as a new player comes into the market or as a new technology comes along. I like to think about our business a little bit like this, if you like, or this is how I explain what we do to people. We start off by making product A. That allows us to make product B and then product C, and the turnover of each of those grows. Then after a while, we'll reversion product A to give it another kick. And if I look at our company at the moment and where we are, we have a lot of products on the right-hand side of the curve, and we have a lot of products on the left-hand side of the curve, and these are kind of dying, if you like, and these are up and coming and new. We've showed you some of those earlier, and I'm constantly thinking about how to rejuvenate some of the older products and how to introduce new products into the market.
So 23 years now in business.
Yeah.
What will the next 23 year bring?
I don't think I'll be sitting here in 23 years' time, but you never know. But I think in terms of how we grow in the future, we're doing a lot more with different types of educational products within technology and engineering, and we're trying to widen our portfolio to be the kind of go-to company for technology education between the ages of 16 and 18. And that's not just in electronics, it's in electrical engineering, motor control, mechanical engineering, and things like that.
Yeah.
So we want to have a broad portfolio of engineering-related educational products. But also we still love that industrial market. And actually between 16 and 18, you've got to have industrially relevant products. So you kind of need to have a bit of a foot in both camps, really. So our Miacs and our Flowcode into industry will also invest in that.
I think this is the first interview I'm having where the famous word IoT is not mentioned.
Oh, really? Well, IoT, if you're purely industrial focused, I guess IoT is a really big thing. And we do have IoT relevant products. In fact, nearly all of them are IoT-able in some way. But because we're educationally focused, IoT is a small part of education at the moment. And actually IoT is much more about computer science probably than about electronics. The electronics side is relatively straightforward. Yeah. The back-end computing parts are where all the complexity probably really is.
Sure.
No,
thank you very much. I really enjoyed being here and have a look around.
Good.
Thanks very much.
Good. Thank you.